Hey everyone, so today we're going to be working with the properties of logs. So up here I just have all the different properties that we can be looking at. So the first one is a to the log base a of m just equals m. And if we look at our first example, we have that same formatting. So 2 base log to the 2 pi. So then this would mean m would equal pi. So that means this equals pi. Next one we have log base a, and then a to the r just equals that exponent. Example B has that same formatting. So log base 0.2, and then 0.2 to the root 2. So that means this equals root 2. Looking at this next example, it's not in our list above, but I know that natural log and e are inverses of each other, so they cancel each other out. So that means we're just left with kt. The next one we're going to look at is using those properties of the plus and minus with knowing when you're dividing or multiplying, and put those into here. So for this first one, we have the square root of x squared plus 1 divided by x cubed times x plus 1 to the 4th. So first I notice this is a division, so I'm going to have a difference of logs. So I'm going to have log base a, and then the square root of x squared plus 1, and then minus log base a to the x cubed times x plus 1 to the 4th. I'm noticing that second part, the log base a, and then x cubed times x plus 1 to the 4th, is multiplying. So I can add those. But I'm going to write it like this because that minus is still supposed to get distributed to both. So I'm going to put it in parentheses. So log base a, x cubed, plus log base a of x plus 1 to the 4th. The next property I'm going to use is the exponent one, the last one, where if the exponent, you can just put it in front of the log. That's like its factor. So this x squared plus 1 is really x squared plus 1 to the 1/2. So I'm going to bring that exponent to the front. So 1/2 log base a, and then now x squared plus 1. And then minus that cubed is going to go in the front. So 3 log ax. That 4 from the x plus 1 to the 4th is going to go in front. So plus 4 log a x plus 1. Then remember to keep that in the parentheses. And then that's as far as it can be expanded. Alright, now this one's a little bit more simple. So we have an x times the square root of x squared plus 1. So this is multiplying, and when you multiply, you can have the similar bases and add. So log base a of x plus log base a of the square root of x squared plus 1. Now we're going to go do that express all the powers as factors part. So as we know, the x squared plus 1 from the previous example has an exponent of 1/2. You can write the square root as an exponent of 1/2. And so we're going to bring that to the front. So log base a x plus 1/2 log base a x squared plus 1. Alright, so now we are going to go backwards. So we have 2/3 log 8 minus, or natural log 8 minus natural log of 5 squared minus 1. So first I'm going to bring that factor back up as an exponent. So I'm going to have natural log 8 to the 2/3 minus natural log of 5 squared minus 1. But I also know that 5 squared equals 25. So 25 minus 1. Next, I'm going to evaluate e to the 2/3. 8 to the 2/3, and 8 to the 2/3 equals 4. So I have natural log of 4, and then 25 minus 1 is 4. So minus natural log of 24. Now I'm going to use my minus as division to combine my bases. So natural log of 4 divided by 24. If I simplify 4 by 24, I get natural log of 1/6. I'm going to even take this even further and separate it back to subtraction of natural log of 1 minus natural log of 6, because I know that the natural log of 1 equals 0. So this is now 0 minus natural log of 6. And 0 minus natural log of 6 is just negative natural log 6. And that would be its very simplest form. If you stopped here, I'd be okay with that. But you would try and get to this negative natural log of 6. Okay, so next we have log base ax plus log base a9 plus log base a x squared plus 1 minus log base a to the 5. And with all those additions, that means we're going to multiply all of those. So log base a, and then x times 9 times x squared plus 1. And then we have that minus 5. So all over 5. And then I'm going to make this look nicer by doing x times 9. So I have log base a, and now 9x times x squared plus 1 over 5. And then I'm going to leave it like that. Okay. Lastly, we're going to look at the change of base formula. So this is just, you want to get both of these, like log base 5 to the 89, to have the same log, so you can enter it in the calculator and solve for it. So if the rule is you just have this similar base, so we would both have these, so it's like log over log, and then the top is 89, and the bottom is 5. So if we go enter this in the calculator, we get about 2.79, because you can't just enter log base 5 of 89 in your calculator. So you'd want to have that similar base that you can just press the log button on your calculator. So now I'm going to use the natural log. So all these things equal the same. So I just want to do the natural log version this time. So I'm going to have the natural log of root 5 over the natural log of root 2. I'm going to put these with the exponents. So natural log of 5 to the 1/2 over natural log of 2 to the 1/2. I'm going to take those exponents and move them in the front as the factors. So 1/2 natural log of 5 over 1/2 natural log of 2. And what I notice here is I got 1/2 and 1/2 simplifies to 1. So I'm left with natural log of 5 over natural log of 2, which if I plug that into my calculator, I get this equals about 2.3219. All right, that's it. If you have any questions,